Let me show you how to do the first assignment. This is a data assignment, and the goal is to familiarize yourself with data about interest rates and inflation that are going to come up again and again in the class, and also to do practice making graphs in Excel, doing manipulating data in Excel or any spreadsheet, which is going to help with later assignments and also help you with your paper as part of the class. So the goal of the assignment is to make this graph. And the graph, this is the real goal is this green thing, the real interest rate. So the red is the, the nominal interest rate on a 10-year bond, U.S. government bond. The blue is inflation, and the green is the real rate. And when you hear the word real in economics, what that means is that it's adjusted for inflation or adjusted for the price level, something like that. So let's be very specific about that. So to be precise, the real rate, real interest rate is the nominal rate minus inflation. Now, if I was being really precise, I should say that this is expected inflation. Now, for this exercise and for a lot of what we do, we're going to ignore that. But just be aware that if we were being really precise, we would take that into account. But for now, let's ignore that. So what does this mean? For our particular example, our real rate is the 10-year yield minus inflation. Okay, so to make this graph, we need data on the 10-year yield, and we need data on inflation. But remember, inflation is the percent change in the price level. So really what we need is data on some measure of the price level in the economy, the average price level in the economy. The government and economists calculate that in two ways. The one you hear about most on the news is the CPI, the Consumer Price Index. The Bureau of Labor Statistics calls up a bunch of households and says, what did you buy? How much did you pay? And they take an average across what they think is a typical basket of goods, and then take the average of prices and throw that all together and come up with a single price level. Okay, so this is where we're going to get our data from. A lot of data comes from Fred. In fact, if you just search Fred, it's the first thing that'll come up. This is the Federal Reserve Bank of St. Louis. Does this, keeps this data bank online. Very convenient source, really the go-to source for data. And when you do assignments or write your paper, I'd suggest this is the first place to start. So what are we looking at? Okay, well here are the two things we need. There's CPI and the 10-year rate. Now this, I need to make sure that this 10-year rate is going to give us enough data. Okay, so this is just the past 5 years or so. Let's see how much they're really giving us here. This takes us all the way back to 1962. I guess that's good enough. I'll just show you if you want if you want more data. Starting from the beginning, we could also go to categories, money, banking, and finance, interest rates, Treasury constant maturity, 10-year constant maturity rate. Let's see if this, let's see if there's an alternative that gives us more data. Well, if we use the monthly data here, actually we get back to 1953. So let's do that. Uh, for your assignment, I think either one is fine. But here's the 10-year rate going back to 1953. So we need this data. So all you have to do is download in an Excel file. So we'll get a file like this. Let's get rid of the this stuff up here. Delete that. And just to check, you can always select the data here and just look at a graph really quickly. So let's insert a line graph, and that looks, about like what we had. Now, one thing you'll notice down here, we don't have dates. We'll worry about that in a second, but I just wanted to make sure that what we downloaded is what we were seeing online. Okay, next step. We need CPI data, price level data. And there's CPI. So, looking at this, one thing you notice is that prices go up over time. Now, this level of prices, this isn't exactly what we need. What we're going to want to look at is the inflation rate, which is the percentage change in the price level. Let's see, and we're going back to 1948 there, so that's certainly enough data. So there's a few different ways to do this. Let's just do it directly, because for one thing, we can use the practice in Excel. Again, we're going to download this. And here's our CPI data. All right, so but we want to merge this. Now, one important point: this is monthly data. The tells you this monthly data. We're going to combine these two data sets, so it's important that we have the same frequency, so that there's both monthly data. Now, we've got more. This goes back to 1947, and the nominal rate goes back to April of 1953. So to match this up, we're going to make a new column for CPI. So let's go back to the other, the CPI data. Go down, find April of 1953. There we go. And let's select the rest of the data from here on down. And let's copy this and go over here and paste it here. So let's make sure we've got, see if we have something that looks like what we had. Yeah, that looks about right. Okay, so we have the data we need. We have the interest rate, we have the price level. But the price level is not inflation. Inflation is the percentage change in the price level. So we're going to make a new column with inflation data. So how do we do inflation? Well, like I said, inflation is it's the percentage change in CPI. But we have to be careful here because it's the percentage change not over the previous, not just month to month, but over a whole year. We want to we could calculate inflation month to month, but really what we're interested in how much have prices changed over the past year. So what do we have? Now, one point immediately. Oops, wrong one. Now, what if we tried to figure out inflation for April of 1953? Well, actually, we can't do it because what we would need data from we would need CPI data from April of 1952. We want to compare those two things. So the first one we can really do is April of 1954. So that's the first piece of inflation data we're going to have. And we're going to be comparing CPI of April 54 to CPI of April 53. So let's just write that down. CPI April 54. Oops. What happened there? And we want the percentage change, so the difference minus CPI April 53. And so for it to be a percentage change, we're going to divide by the original CPI, CPI April 53. And to make it a percentage, let's multiply the whole thing by 100. So there's inflation for April 54. So that's what we need to put into Excel. So how do we do that? Okay, so we're going to have, so first of all, the magic function here in Excel is equals. That's going to give us the full functionality of the spreadsheet to help us out. So we want to do 100 times CPI, this 2685. Now we could type this in or type in the number of the cell, the C14, but the easiest thing to do is just click on the cell. We want this one. Now we want to subtract from CPI April 53, so that's this one here, and divide by CPI of April 53. So let's see if we get a reasonable number. 0.63. That's reasonable. Let's make this number 0.64. That's a reasonable number. It seems kind of low for inflation, but let's see how the rest of them turn out. Now, we could go down here and do the same thing to figure out inflation for the next one, but the whole point of using a spreadsheet is that if we just grab this bottom right-hand corner and drag down, it's going to do it automatically. So take a look at the command line up here. So here we were comparing April 54 to April 53, so that's C14 and C2. But now we want May of 54 versus May of 53, so that's C15 minus C3. So the spreadsheet automatically takes care of this. And in fact, we can do this for the whole column. And that is the whole point of using the spreadsheet and using equals to make that calculation. And there we go. So let's see if we get something that looks like inflation here when we graph it. That looks about right. Again, we're going to need to talk about the dates, but that's we'll do that in a second. The last step is to calculate the real rate. So remember this, our goal besides was not just to get inflation, but to calculate the real rate on this 10-year yield. So take the 10-year interest rate, 10-year yield, and subtract inflation. So here, let's call this the real rate. And again, we'll have to start down here, but we just want to take the, again, equals the nominal rate, which is just our yield data that we downloaded, subtract what we calculated for inflation for that date, and that's the real rate. And same idea, we can drag this whole thing down. And now we have the data that we wanted. So the original graph had the nominal rate, inflation, and the real rate all together. So how do we do that? Well, so here, let me just show you a couple ways you can try this and point out a couple pitfalls. Let's just say we grab all these and try to graph these all together. Well, that's a mess. So what happened? Well, the problem here is we're including the CPI data. So all the other data here, inflation, the nominal rate, the real rate, these are percentages. You know, things like, you know, typically 0 to 10%, maybe gets a little over 10%. CPI is a totally different scale. So when we include that, all we're seeing CPI and then a bunch of really small stuff. So I could deal with that. I could go select data and get rid of CPI, and now we get something that looks right. Or, you know, from the beginning, you can just use the control function, select this, and this, and this, holding down the control key, and now create our graph. That looks nice. But now let's talk about the dates here. So what we have on the horizontal axis is just the numbers of the rows. So let's go to select data, and we want to edit the horizontal axis. So we're going to click on edit, and now you could enter some fancy stuff, but really what we want is these dates. So let's just click on that column, and it should automatically put in some dates. So from here, what we really need to do is format. We have the right data, we have the dates. There's a little formatting we can do to make this look nice. Let's change it to give it its own sheet here. What would we like to do? Let's give this, we don't really need the title. It would be nice, we have a legend down here. Let's, I wonder if we can make this a little bigger. Let's make this, how about 16? That's nicer. Maybe even a little bigger. No? Okay, so we've got a nice legend there. What about the dates? Um, it would be really nice if we could move the dates because we have this, the real rate goes negative and kind of crosses the dates. So the way to do that is we were formatting the axis. Actually, this is the wrong one. We need to format this axis. And let's make the horizontal axis crosses, let's say -6. Now we have the dates in the right place. It's also nice to format these dates a little bit. Um, this custom angle is nice to just make it a little bit easier to read. Now, if I was if I was going to continue, I might make the numbers here on both axes a little bigger, a little easier to read. But this is the formatting basics. We've got the basic graph. I'll let you do formatting, how you see fit to make this look nice. And different, I don't want to get too far into it because different programs have, different versions of Excel or different spreadsheets might have different ways to change that. So I don't want to take time doing that. All right, but you have the graph. Now in the assignment, there's 2 or 3 questions that go with it. There's also a podcast you can listen to that will help you, uh, identify some of the, one of the big changes here. One big change that you can detect looking at the real rate that might not be obvious otherwise. So I'll let you listen to that. For the assignment, you should submit one PDF document. So I would recommend making this graph, pasting it onto a Word document, then answering the questions on that Word document, turning that whole thing into a PDF, and then you can upload that on ReggieNet.